Hello, everyone, and welcome to today's Help Systems webinar, When Database Server Jobs Attack, coming to you from beautiful Eden Prairie and Rochester, Minnesota, here in the USA. Thanks for joining us. As we mentioned, today's webinar will last approximately 30 minutes, and we will be recording the webinar, and you'll see a follow-up email with a link to that recording. So, oh, how we love QZDASOINIT jobs, don't we? These JDBC and ODBC requests to the database help enable the open database world we live in and have lived in for quite some time. But as we've seen, poorly written SQL statements, massive file joins, or requests that multiply before your eyes can bring your IBMI system to its knees and leave your end users twiddling their thumbs. So don't wait for that call. Let's be proactive about monitoring and identifying these processes. My name is Chuck Lisinski. I'm the Director of Technical Solutions at Help Systems, and I'm joined today by Terry Preston, who will be monitoring questions. Terry, say hi.
Hi, everyone. I'm your tech support person when you call in for issues.
Yeah, absolutely. And of course, there's a number of people backing up Terry. And as mentioned, if you do have any questions today, make sure you send those in, and we'll answer those closer to the end of today's presentation. It's going to be a fairly fast-paced webinar, so let's get started. If you have not been exposed to a robot monitor, this product joined the robot family a few years ago now, about 3 years ago now, and we've been putting a lot of research and development dollars into this tool. It's no longer just an IBMI tool, it's also a VIOS and AIX monitoring tool, and we've been enhancing it around SQL and of course these JDBC, ODBC connection monitoring. If you're working in a multi-partition environment and want to do, for instance, a PTF comparison across partitions, we have that functionality, real-time data collection, summary reporting, etc. We bring this into the graphical interface so you can visualize it, but also behind the scenes, we're also doing real-time notification. That notification can be sent out via robot alert, robot network if you're in that environment. And a little bit about the architecture of robot monitor. The robot monitor central host system is where all the data from your monitored partitions will reside, and that's where you'll connect the robot monitor graphical client to. The other partitions report up to that central monitor. We have our own data collection tools on each of those partitions, including the host central partition, that collect the appropriate data very quickly and efficiently. And the data is stored using variable length fields in our DB2 database. So the data is compacted on the way in, so we're being very efficient with storage utilization as well. So we're going to focus in on job monitoring. We've got a number of other recorded webinars and future webinars also planned around some of the other functionality in Robot Monitor, but certainly go out to our website and you'll see some additional webinar collateral. But let's focus on job monitoring and JDBC, ODBC, and batch monitoring as well. But we'll start out with remote database connections. We'll talk about real-time monitoring, batch monitoring, historical reporting, something called Hinder jobs, and of course, we'll have some time for Q&A. So let's first of all just quickly review these remote database connections. You know, we've been hearing more and more from our customers that this is a real challenge that they're having out there, because with the modernization that's going out, we're seeing more remote access to the DB2 database. And these are in the form typically of ODBC or JDBC connections back to the database, the infamous QZDASOINIT job. Those are spun up as needed, typically show up in the Q user work subsystem. You do have some ability to redirect these jobs to different subsystems. If you want to review some information from Dawn May, she talks a little bit about how to redirect that activity to different subsystems, which might help your work management a little bit. I've also spoken with a couple of customers recently that have DDM, DRDA connections in the form of a different job name. And these are pre-start jobs. So if you're potentially using that protocol, if your developers are using that protocol to share data across partitions, those can also be a bit of a problem. And then there's something called SQL server mode. And these jobs spin up automatically if your application uses a native JDBC driver. Otherwise, it can be initiated programmatically. So these are some other jobs that you might want to pay attention to. So all these jobs combined, of course, with your batch and interactive can certainly be difficult to monitor. And that's what we want to talk about today a little bit in the robot monitor architecture, is how to set this up and how to monitor and how to get notifications set up around this, and even how to take some action. But first, we want to hear from you. So we're going to launch a polling question. And the question is, where do you struggle with job monitoring? So maybe you have no monitoring for user queries or external apps, no visibility into problematic SQL statements, no notification for jobs consuming too much CPU, for instance, no way to report on job or subsystem performance, no easy remediation for problematic jobs. This is a big deal out there, and obviously when we talk to many hundreds of customers and prospects every year, and we get this sort of feedback, and so that's why we've implemented this technology and why we're continuing to enhance it. Thanks for responding. We're getting a pretty good mix here. Give you just another 10 seconds or so to respond. And Terry, I'm going to throw this at you. Do you hear much about this when you talk to your customers?
I do hear a bit about it, but you know, I'm sorry, Chuck, I kind of lost my voice for a second there. Yeah, I do hear it when the customers call in a bit about this. So
okay, so let's close the poll, and we'll share the results. Okay, so 61% of our participants have no monitoring for user queries and external data access, 61% no visibility, 29% no notification, 21% no way to report on this, and 64% no easy remediation for problematic jobs. Excellent. Okay, super feedback. Appreciate that. Let's forge ahead and show you some of the possibilities. We'll talk about real-time monitoring in Robot Monitor. Okay, so what you're looking at in front of you right now, these are all the various metrics that you can collect using Robot Monitor for the IBMI side of the equation. Robot Monitor can actually monitor IBMI, AIX, and VIOS partitions. And this is a pretty complete list of everything that's available for IBMI. So we just picked a few that you might want to consider when it comes to monitoring QZDA or JDBC, ODBC type requests: CPU usage, disk I/O, faulting per second, job count, QTemp, temporary storage per job. So these are the kind of things that we've heard from customers that they want to monitor. So what you're looking at now is, for instance, how to set up a CPU usage monitor specifically around this activity. So inside of Robot Monitor, you'd say, okay, I want to create a new CPU usage monitor. And then under the data collection side of the monitor definition, you would select your QUser work subsystem or whatever subsystem you're interested in, and simply right-click on the field, and it'll show you those jobs that are active. And in this case, we picked the QZDASOINIT type job, okay? So very easy to set that up. I'm gonna show you this live. And also over here on the far right-hand side of the setup, you'll also see where you can choose which partitions to collect this data from. All your monitored systems, or maybe just certain monitored systems, okay? Now, as part of this too, you also have the ability to set up thresholds, all right? And what happens with those thresholds? We can send out notification, all right? So we'll show you, for instance, here where I've set up a 50% CPU utilization threshold for my QZDASOINIT type activity, all right? And I only have one threshold set up. I could have multiple. All right, so the thresholds from a visual standpoint will be color coded. You can associate icons with those thresholds, and then you can define exactly what's sent out either via a message, via robot alert, or directly into robot network if you utilize that robot architecture. Okay, so the types of notification can look like this. We can send a message out to a message queue. We have a specific message queue dedicated to Robot Monitor. Certainly you could monitor that message queue with a message monitoring tool like Robot Console. If, for instance, you're consuming too much CPU for these JDBC or ODBC SQL type activities, that could trigger a Robot Console message set that could do, for instance, a plant cache dump. If you're interested in seeing that, I actually have that set up on one of my internal systems. Robot Alert, if you're using that, all right, we could send out Robot Alert, and then certainly into the Robot Network Status Center, we could post those type of thresholds as well for centralized monitoring. All right, so as you can see from the Robot Monitor graphical interface, there's a lot of things we can monitor, and there's probably really too much that you might want to look at to get into one view. So we have something called groups. All right, so in the graphical display, you can group metrics together. So you can see here, I created a separate group for my QZDASOINIT type activity. All right, CPU, current CPU utilization, total CPU, disk IO, number of jobs, etc. All right, so I've actually broken those out, and I can just focus on those when I need to. All right, now how does the drill down work? Okay, well, let's say I get notification that my JDBC activity is consuming too much CPU. All right, so I can immediately go to the graphical interface and I can drill into that activity, and I can see exactly what jobs are consuming CPU or disk IO at that time, and I can drill into the job, and we've recently made some enhancements to the work with job information. So now I can see things like library list, call stack, open files, and we have SQL visibility as well. All right, the SQL command visibility here in the graphical interface, so you can immediately get some feedback. All right, let's take a look at the graphical interface. So this is the Robot Monitor graphical interface, and what you're looking at is a dashboard that includes multiple systems. I have 3 partitions. In this case, they're all IBMI partitions I can combine. This is Academy, Earl, and Wisdom, current CPU utilization, batch CPU, not much going on in batch right at the moment, disk percent full, number of spool files, and QEZ job log. You can see here my Wisdom system looks like it's a lot busier, and actually that's unusually high. All right, so it's color-coded red. I might want to go look at that. If I'm having program dumps, QEZ debug might be able to tell me that. How long have these systems been active? Here's my JDBC CPU, current JDBC CPU utilization, and so forth. So you can see there's a wide variety of things we can check. We can present it to you either in, here's what's happening now, real time in the last 30-second iteration, or we can show you historical information as well. All right, now I'm going to drill down into one partition, my Wisdom partition. And at the same time, I'm also going to run an SQL statement. This SQL statement is going to populate a table with about 8 million rows here. So I'm going to run that right now, and you're going to see what happens here out on the system. And while we're waiting for that, in this single system mode, if these abbreviations don't make a whole lot of sense, all you have to do is hover on the particular metric, and you'll see, all right, exactly what the metric is. All right. So in terms of putting this in the hands of, for instance, somebody in operations, you should be able to do that. So here's JDBC CPU. You can see it's increasing. I can immediately drill into the details, and I can immediately work with that job. And I can immediately drill into the SQL information. All right, so we've made that visible. Also, you'll also be getting notification. All right, so here's my robot alert notification that I got. All right, so odds are you're not going to be looking at the graphical interface 100% of the time. I mean, even if you do have a data center or an operations center, the GUI may not be up for some reason, or maybe it's cycling through other displays. All right, so with this message also that we posted to a message queue, we could also run a robot console message set which I did, and I actually did a plan cache dump. All right. So, we could potentially go out and look at that too. So a couple ways we can look at this information. I can either look at specifically just those jobs associated with JDBC and ODBC, all right? And so with my CPU monitor that I have set up for that activity, the data collection looks like this. I'm looking at my Academy system, my Wisdom system, and I'm looking at QZDASOINIT job names. I didn't even specify a subsystem in this case, because maybe I've used some of the routing that you can do with these jobs. Now I want to look at all my subsystems for that type activity. Okay, you can see it's settled down. All right, if I double click on it, you can see we had some spikes. All right, so what I can do is I can drill back into these spikes historically to see what activity was running at that time. All right, so when we go out and we do our 30-second checks on the system, we're also collecting these top CPU and disk IO consuming processes. So you do have that historical data as well. All right, and we'll look at the how you can look at the summary data and report on the summary data here in just a second. All right, so let's move in now to batch job monitoring, and we'll kind of focus on quote unquote Q batch, but this can also be kind of a pain. Okay, monitoring those batch activities. All right, these batch activities might be coming from a job scheduler like Robot Schedule. They might be coming from the native scheduler. They might be batch jobs submitted from a graphical interface. They might be batch jobs submitted from the green screen. Who knows? Okay, so what we've got is a number of options in Robot Monitor for monitoring batch activity. All right, so for instance, here we have batch jobs on a held job queue. We've got 12 batch jobs that are sitting in a job queue, and the job queue's held. Okay, that's a problem. Notice that the Q batch job queue says it's released, so it's not in Q batch, but it might be elsewhere. So you have now been tipped off to the fact that there are jobs sitting out there on a held job queue. Okay, now if you did have a job queue that was held, for instance, here in the middle, you can see Q batch is held. I can right click on that and I can release a job queue right here from the graphical interface if I have authority to do so. Okay, maybe you want to keep track of number of active batch jobs. Okay, looks like we got 7 batch jobs that are active in Q batch. And likewise, if they've been running a long time, we can keep track of that. All right. So one of the things, of course, you might want to do is track the CPU usage for these batch jobs, just like you can track the CPU usage for your QZDASOINIT type activity, and you can drill into that. All right, so here's my batch CPU. You can see I'm using some shared processor across multiple partitions, so we've exceeded 100% CPU. But regardless, I can drill into that. I can show the details, and you can see exactly what batch activity is out there, and you have the ability to work with that job, see the job log, SQL statements, so forth. And some of these batch jobs certainly could be executing SQL type statements. Okay, let's take a look at that. I'm going to pick a different system. I'm going to look at my Academy system now. Okay. And I've set up a specific group. Remember, we talked about groups and how you can take all the various items that you're collecting using Robot Monitor and you can group them. All right, so this is basically my base group. And I've got multiple other groups listed down below. And one of them is my batch jobs. All right, so for instance, I've got 16 jobs on a held job queue or held job queues. Okay, I've got 16 batch jobs held on job queues across my system. Okay, why are they out there? Why are they held? Here's number of jobs on held job queues, 12 jobs. All right, I also have 12 jobs active in Q batch. How do I know that? All right, so I set up a job queue, active job count for a specific job queue. And I'm looking at all systems. Queue batch is, of course, quite common. So you could actually set up a dashboard to see all your batch activity across your entire environment. In this case, I'm looking at a single environment. Okay. And right down here, it says runtime, 55 minutes. Okay. So it looks like I've got some batch jobs out here, invoicing batch jobs, and they've already, all these jobs have been running for 50 some minutes. They're all submitted by Chuck. Looks like Chuck got a little overzealous. Things weren't happening fast enough, and he just kept submitting more and more jobs. That's not uncommon. So what would you do with something like that? I mean, how would you overcome that? Well, you might go out to your green screen. You might do a work with your job queues potentially. All right, work job queue. Here's all your job queues, and look at that. Here's my plant 1 job queue. It's held. All right, I've got 16 jobs queued up here in queue batch. Okay. So you've now been tipped off to the fact that you may have issues with your batch environment. You've had some notifications sent out, no doubt. All right, you can see we have some color coding going on. All right, so I have set up thresholds around this activity, job queue count. Let's go to my batch activity. Okay, so I've set up 2 thresholds, 10 and 20. I can set up notification to go out based on how many jobs are queued up, how many jobs are held, how many jobs are running, how long they've been running. All right, so that's also one of the batch thresholds you're going to want to keep an eye on. Okay, so if my jobs are running longer than 120 minutes, you might want to send out some notification. Okay, let's take a look at historical reporting next. Okay, so we're doing real-time data collection. Every 30 seconds, we have this detailed data. What we do with that data is we summarize it. We summarize it by month and by day and by hour. Okay, so for instance, for the month of November 2018, one of the things we were watching is disk busy. And we actually had some performance problems on my Wisdom system. We determined that we didn't have enough disk units associated with this particular partition. So we did a little before and after analysis, and when we added additional disk units, our disk busy metric dropped from between 6 and 7% down to less than 2%. And our performance improved quite dramatically. We were a bit IO bound. All right, so with this summary activity, summary reporting, we can compare activity. So for instance, here I'm comparing using a shaded line graph, CPU for my JDBC type activity, disk IO for my JDBC activity, and temporary storage, all on the same graph, and this is by month. All right, so this is the last 12 months worth of data. Often our customers keep even longer amounts. This is more of a bar graph approach, comparing overall CPU usage, disk busy, and non-database faults. All right, so as I mentioned, we summarize by month and by day and by hour, and I can drill into this activity and get down to that top jobs list, that detailed data, as long as I have it. I can print any of this data directly from the GUI. I can also automatically generate summary or detailed reports. And these reports can either be run via a command or they can be run via the graphical interface. Just click on run or run an email, and those graphical reports will be sent out. So let me just show you real quick the drill down capabilities. All right, and we'll jump on Wisdom here. All right, and let's look at, let's just keep it simple. We'll look at CPU utilization. Okay, so here's my detailed CPU utilization over the past 9 hours. You can choose how much you want to see in this view. All right, so from here, we could drill into the history summary. All right, so here's my CPU usage for the last 12 months. One of the options you have with this display is something called translated. Okay, so based on all the historical thresholds that you've set up across your CPU utilization for any particular workload or system overall, this is going to tell you by a percentage of time for each month or for each day or for each hour when you exceeded a threshold. Okay, that's called translating. Okay, likewise, I could drill into any month. All right. For instance, I could drill into January. January overall, 27.2% was my average utilization. So now it's downloading the daily averages. Here's my daily averages for this particular metric. I could drill into last Thursday. Here we had a spike. Maybe I was doing a demo at that time. Now it's downloading the detailed data from that 1 hour time period, okay? And if I drill into that, now here's the detailed data, and you can see we had some guy by the name of Big Chuck was running some batch activity at that time. All right, so I'm going back in time doing some historical reporting. Okay, the last topic for today, we just got a few minutes left. And before I jump into this last topic, I'm actually going to run some activity on my system. All right, I'm going to submit some activity that's going to be consuming quite a bit of CPU. And what I want to happen with that is I want those jobs to be automatically either placed on hold temporarily while CPU is high, or I want their run priority to be reduced. And the way I'm going to do that is with a command that you can embed into Robot Monitor called moncheck JCP. It's called check job CPU and hinder. And basically what happens if a job exceeds a CPU threshold, we're automatically going to reduce the run priority of that job, or if you'd like, we could put the job on hold temporarily. And then what happens is once the overall CPU utilization is behaving, we'll increase the run priority of that job and or take it off of hold. All right, and you can have multiple instances of this command running. So for instance, maybe you want to reduce run priority for QZDASOINIT type activity. All right, that's basically what I have here. So in this case, we're going to lower the run priority. Maybe for some batch activity, you want to put those jobs on hold temporarily until the CPU is back where it needs to be. So I'm going to call this throttling back offending jobs. All right. Let's take a look at what we've got on my wisdom system. All right, we'll jump into the monitor. All right. All right, so I just submitted these, and there's about there's an iteration that's going to take place of about 1.5 minutes. And what you're going to see right here is my monitor to check job CPU and hinder. All right. And here under my data collection is my moncheck JCP command. All right, and it's there where we're saying, okay, we want to look at the CPU for this activity. And in this case, I'm only looking at QBatch. And at this point, I'm going to lower the run priority of those jobs by 20 when my CPU has been exceeded. All right. And Terry, I probably should have submitted these maybe a couple of minutes ago. Here we go.
It takes
Here they
it a second to hinder it.
Yeah, and you want that. You want to give them a chance to run. All right, so let's show the details on this. Okay, so these were batch jobs submitted at a run priority of 50, and automatically we lowered them to 70, and it's actually going to lower them another 20 here in another 1.5 minutes, depending on the cycle that you have set up on that command. So this is called check job CPU and hinder, automatically reducing run priority or placing those jobs on hold, depending on how much CPU that they're consuming. All right, so you can actually take action on those QZDASOINIT type offending jobs or any job activity on the system. All right, so that was a very quick robot monitor live demo and a little bit of explanation of some of the job monitoring that we can do in robot monitor. I am available. Terry is monitoring questions, and while we're queuing up those questions, I'm going to launch another polling question, just asking if there's any follow-up that we could provide you. All right, and in terms of questions, Terry, I think we've got a couple. Okay, so one question, and I guess I alluded to this up front, and Terry, I'm going to let you field this one. Does Monitor work only with IBMI?
No, it does not. It works with a number of other platforms. I think Chuck showed a couple of those as groups, so we can work with AIX, we can work with VIOS, and of course you'd be monitoring different different thresholds with those databases.
Right. Yep. And what information can be part of a dashboard, and how many dashboards can I have? Okay. Well, you can have as many dashboards as you want. You can have real-time data, historical data, summary data. You can combine, for instance, VIOS and AIX and IBMI data, et cetera, all into the same dashboard.
And I like that they're shareable, so you could
Oh,
create one.
yep, yep. And we do have a webinar out there on our website as to visualizing using Robot Monitor. We have one more question, and then we're going to conclude the webinar. Can you also raise utilization unhindered when CPU is available? And Rick, absolutely, it will happen automatically with that functionality. Okay, that's all the time we have for questions. We are at the bottom of the hour. Appreciate your time today. You will be receiving a follow-up email with a link to this recording. Share it with your friends and family. And if you do have any questions, please feel free to reach out to us. Thanks for your time today, everybody. Have a great day. Bye-bye.
Bye-bye.